here's the situation. Say, if I roll a dice 10 times, if I roll a dice 10 times, what's the probability of getting, say, 3, a number 3 on the dice, 6 times? Obviously, if I roll the dice once, then the probability of getting 3 would be 1/6, right? But if I roll it 10 times, what's the prospect of getting 3 6 times? Right? Or say, A beats B in a game 3 out of 4 times. A beats B in a game 3 out of 4 times. What's the probability that A beats B 10 times in 15 games, say, for example? Or say, if I toss a coin, $20 times. If I toss a coin 20 times, what's the probability of getting a head 16 times? Right? There is a structural similarity in all these situations, if you think about it. There is some commonality. All these situations belong to the following category. So just to formalize all these situations, in this case, what event are we talking of? The event of getting 3, right? What's the event that we are talking of here? A beating B 10 times in. The event B is like A beating B in a certain number of games, right? This event is getting a head, right? Now, so in a situation, if I have an event A, there is an event A, and the probability of the success of that event, which is called PA, probability of the success of that event, A, if that's Q, P say, let me call it P, probability of the success of that event is P say. Failure of that event is like P, A complement. That's the probability of the failure of that event. That's the probability of the failure of that event. That's Q, right? In an experiment, there is success of an event, A, which is P. The failure of that event is Q. Very clearly, if I perform the experiment, either A will occur or A bar will occur, right? So it's easy to see that P plus Q has to be 1. Because either one or the other would have to occur, right? P plus Q has to be 1. Now, say, so this is in one trial of that experiment. In one trial of that experiment, right? In this case, we are talking of multiple trials, right? A beating B, or A and B playing a game that is performed 15 times, right? Number of trials are 15. Rolling a dice 10 times. Number of trials are 10 here, right? 10 trials. Tossing a coin 20 times. This experiment is performed 20 times. Number of trials are 20, right? So the experiment is performed in one trial of that experiment. In one trial of that experiment, the probability of an event A is P and A not happening is Q. P plus Q has to be 1, right? In this case, the event of A beating B. That's the event. That's the event. Probability of that event in one trial is very clearly 3 by 4. It's very clearly A beating B. The probability of that event of A beating B, call it PA, is 3 by 4 in one trial. In this case, what's the event? Well, in one trial of that experiment, getting 3. The probability of getting 3 in one trial is 1 by 6. Probability of the event A here is 1 by 6. The event is 1 by 6. Right? Tossing a coin to getting a head. The event is about getting a head. And in one trial of that experiment, probability of that event is half. Yes or no? Right? So, I'm talking of one trial of that experiment. The probability is P of that event A taking place. Success of that event, we call it success of the event A. We call this failure of the event A. This is technically referred to as success of event A. We call this failure of the event A. In one trial. I want to find the probability of success of that event. I want to find the probability of the success of that event a certain number of times, right? If I perform the experiment n times, I want to find the probability that it was successful r times, right? So I want to perform the experiment. There are n trials of this experiment that I'll perform. There are n trials of this experiment that I'm going to perform. And I want to find the probability of the success of this event in r trials. Probability of success in r trials. You know what I'm saying? In one trial, the probability of the success of that event is P. In one trial, the probability of the success of the event is P. I want to find the probability that the event is going to be successful r times in n trials. Do you understand the problem? Probability of success of the event, which is A beating B, is 3 by 4. I want to find the probability of success of this event 10 times out of 15 trials. 15 trials, and in 10 trials I want it to be successful. What is this? Probability of success of that event is 1 by 6. I want to find the probability that it is successful 3 times when performed 6 times. Right? What about this? There are 20 trials of that experiment. Probability of success of that event, what's the event? Of procuring a head. Probability of the success of that event in one trial is half. I want to find the probability of its success 16 times in 20 trials. 16 times in 20 trials. That's a problem that I'm addressing. Right? Very simple. So, these are my trials. T1, T2, Tn. N trials. Alright? These are the N trials. And probability of success in each trial independently is P. They are obviously independent trials. The outcome of one doesn't influence the outcome of the other one. So they are obviously independent trials, needless to say. Now, I want R successes. That means I want n minus r failures. That means I'm seeking n minus r failures. Out of these n trials, I want r to be successful towards an event A. R to be successful towards an event A, right? That means n minus r failures right? Now, what is it that you would do? Out of these n trials, you want to select r successful trials? You want to select r successful trials? Yes or no? In how many ways can you select r successful trials from n? NCR ways. NCR ways. So select the r successful trials in NCR ways. Select the r successful trials in NCR ways, right? And then r of these trials are successful. So the probability of success is p. So I'll have, for the r successful trials, the probability then would be p into p into p into p, p to power r, p to power r. And q failures, n minus r failures, and the probability of failure is q. So those n minus r trials are failures. Those n minus r trials are failure, each with probability q. So that will be q into q into q, n minus r times q to power n minus r. Not a formula. This is not a formula. It's only a concept. It's a situation of combinatorics. See, there are these n trials. There are these n trials. I want r successes. I want to find the probability of getting r successes in n trials, right? So first of all, you'll select the r successful trials in NCR ways. Yes or no? Huh? And now, for each of these r successful trials, the probability is p. So p into p into p into p, r times p to power r, and n minus r failures, right? So which is like q into q into q, n minus r times. Yes or no? Q to power n minus r. Yes or no? That's a probability of success in our trials, right? Do you also? No, that doesn't mean the rest. I mean, I've selected R of the type P. So there is a probability, and there is also a probability of the rest being failing with probability Q, right? Which means now, do you also realize, although it's not important, this is also coefficient of x power r in q plus p to power n? Yes or no? Do you realize this is coefficient of x power r in q plus p to power n, binomial theorem? Let's look at all these situations in light of what I just did. The event of A beating B. First situation, event of A beating B. The probability of A beating B is 3/4. The number of times this experiment is performed is 15. And how many successful events I want? 10 successful. So P is 3/4, failure is 1/4. I want this to happen 10 times and I want this to happen 55 times. In 15 times, I want this to happen 10 times and this to happen 5 times. Yes or no? So what would I do? Out of 15, I'll select 10 of this kind first. So that makes it 15C10 into 3/4 to power 10 into 1/4 to power 5. That's the probability of success of this event. If someone says, what's the, let me revise this. Do you understand this? This is the probability of success of this event 10 times out of 15 trials, right? Now I modify this a little bit. The probability of A winning, probability of A beating B, at most 10 times. At most 10 times. You know what I'm saying? Probability of A beating B at most 10 times. So first of all, probability of A beating B 0 times. 15C 0 into 3 by 4 to power 0 into 1 by 4 to the power 15. A beating B 0 times. That's a probability. Plus A beating B once. So that's going to be 15C1 3 by 4 to power 1 into 1 by 4 to power 14. A beating B exactly once. Or A beating B twice. So that makes it 15C2 3 by 4 whole squared into 1 by 4 to power 13. Right? A beating B twice. And going this way up to A beating B 10 times. 15C10 3 by 4 whole to power 10 into 1 by 4 whole to power 5. A beating B. So this is the probability of A beating B at most 10 times. So he could have beaten him 0 times or 1 time or 2 times, 4 times, 3, 10 times. If someone said probability of A beating B at least 10 times, then I'll start with this term and then go up to 20. I'll start with 15C10 3 by 4 to power 10 etc. 15C11 3 by 4 to power 11 1 by 4 to power 4 and so on and so forth. I'll go up to 15C15. I'll go up to 15C15 3 by 4 to power 15 into 1 by 4 to power 0. That's what I'll do. Right? So I can find probability of success of an event exactly R times, or at least R times, or at most R times. All of this we can find using this idea. Yes or no? So now you know what about this now? Getting 3. Probability of the success of that event is 1 by 6. Right? How many trials are performed? 6 trials. So 6, out of which how many we want? 3 successes. 10 trials are performed. Roll a dice. Probability of getting okay. So 10 times the experiment is performed and I want 6 successes. So 1 by 6 to power 6. That means Q is 5 by 6 to power 4. Yes or no? Do you understand what I did here? नहीं समझ में आया? देखो, I'm rolling a dice 10 times. ठीक है? And what's the event that I'm talking of? Getting 3. So if I roll the dice once in one trial, what's the probability of getting 3? 1 by 6 क्या है ना? अब this I want the probability of getting 3 6 times out of 10. That means I want 6 successes in 10 trials. ठीक है? तो जो 6 successes I'll have to select in 10C6 ways. Or probability of success of that event is 1 by 6 to power 6. बाकी 4 क्या हुआ? 5 by 6 failure to power 4. Right? This is the failure of that event which happens 4 times. This is the success of that event which happens 6 times out of a total 10 times. This is what is transpiring here. Yes or no? Confused? No? Okay, so that's as far as this is concerned. Let's look at this. Toss a coin 20 times. What's the probability of getting a head? 16 times. So probability of success of that event in one trial is half. Right? Now I'm going to perform that experiment 20 times and I want 16 successes. So first of all, out of 20, select 16 successful trials and then half happening 16 times. And the remaining half, which is also 1 minus half, probability of that event not happening is 1 by half. That happens remaining 4 times. That happens remaining 4 times. Simple?